Hi, it's Paul here. Welcome to Cisco CCNA in 60 days. Books on Amazon if you want to check it out, version 4. Please subscribe to the channel, like the video and hit the bell if you can, so you see all the other videos. So today we're on 18, which is static routes or routes if you're in America. Static routing. As always, read the cram guide which you got on day 0 or day 1, the links to. Watch the videos, do the labs, take the online exam. I always recommend you review the day before as well if you can. You don't have to look at it all, just look at the main points. Go to subnetting.org or 101 Labs IP subnetting. So today we've got static routing for IPv4 and IPv6. We've got some labs to do, so you can hop on. I think they'll work on Packet Tracer, but just copy along with what I do. And it doesn't always have the same commands or work in the same way. There's a few books that will help you. 101 Labs IP subnetting from Zero to Guru, and there's 101 Labs Cisco CCNA. So without further ado, we'll go into our presentations. Static and default routing for the CCENT ICND1 exam. So static routes, they're something that's manually configured by the network administrator. Generally, in a network, if you've only got a small handful of routes to get from A to B or wherever on your network, then it may not actually be efficient to run a dynamic routing protocol, because obviously you've got the extra overhead on your network of the traffic passing, the hellos, and also the CPU utilization on the devices. You can obviously have a mix of dynamic and static routing on your router. A lot of the time static routing is used for remote networks, small offices that can really only send all of their traffic to a backbone router anyway, so there's no need to run a routing protocol on it. Static routes are preferred over routing protocols. There is an exception to that, which I'll show you in a moment. A static route, because you've manually configured it, is given a better administrative distance, because obviously you should know better how to configure your network. Now they can't go down, so this could lead to problems if wherever you're sending your static route to is no longer available, because the traffic will still be sent. You must be familiar with the command line to enable or to configure a static route. As with everything, I recommend you try all of these commands on a router, on Packet Tracer or GNS3, because there's no way you remember them otherwise. You type the IP route to the network and then the prefix mask, the subnet mask, and then you'll normally add the next hop address or an exit interface. There is an optional command at the end which I'll cover, which adds an administrative distance. So here we have a very simple network, 172 and a 192 network on the far right. On the left-hand router, there's no point in running a routing protocol, so what I've said is IP route to get to the 192.168.1 network. I've added the subnet mask. Just be careful, because in the exam they'll try and catch you out and put a wildcard mask, and because you've spent a lot of time studying access lists and OSPF, you may possibly just get confused and second guess yourself, but it's a subnet mask. The next IP address is the next hop address I've put. I could have put an exit interface to leave or send the traffic through, but instead I've put the next hop address of the right hand router. Now often you will be working for a customer, and I've gone and done some consulting work, and the customer's got a router, they have an IP address, but then they can't give you the next hop address to send the traffic to. They've just literally got a connection they've bought from their ISP. So what you could do is specify an exit interface, and in this instance I'm sending all traffic to all network to the serial 0/0 interface. Now bear in mind, you can't do all the zeros and then 255, 255, because a 1 which is the 255 signifier 1 in binary, means match. So it will only match an address that is 0.0.0.0. So we don't want that. We want the zeros, which means don't care which bits are matched. Now this negates you having to run more complicated protocols such as BGP. You just send all your traffic to your internet service provider in this example. A floating static route. This is a preferred route after a route with a better administrative distance. So I've got an example here. Say you've got a high-speed link, which is signified with serial 0/0, and you want some sort of backup just in case that link goes down to be able to reach the remote network. Now I know that there's probably other ways to do this, but I just wanted to illustrate the point of a floating static route. Now say your link via serial 0/0 goes down. What I've done is I've configured a static route, but I've added an administrative distance on the end of 200. So what that means is it will only be preferred if there isn't a better route to get to that network. And as long as the ERGRP is running, which internally runs an administrative distance of 90, that link won't be used, the slower link won't be used. Now the minute the better link comes up again, the route will be installed on the routing table for ERGRP, and then the floating static route will no longer be used. Now this is an exam topic, as everything else is, so make sure you're familiar with it. IP default gateway. The only time you'll add this command is when IP routing is disabled. So just bear it in mind. They may ask you about it or may give it you as one of the options in the exam, but the only time it will be used is if somebody's put the command no IP routing on your router, which wouldn't be a good idea. IP default gateway, and then the IP address is the command. Default route. So this is we want this to be matched if no better route exists. So it's giving our router an option to send traffic somewhere if there's no better way to get there. Generally, again, the same with I mentioned earlier with static routes, it can save you a lot of headaches and make administering the network a lot easier for you. So for example, on the left, we've got 3 hub routers. Really, is there any point in configuring routing protocols on any of these routers? Because if the top router needs to reach the middle or bottom router, whatever happens, it still has to go to the hub router on the far right hand side. So why have all of this traffic passing on your network? Why introduce more complexity when you don't need to? All you would do is they're all connected networks. You would have one, just hit the next button, you would have one default route on each router on the spokes pointing to the hub router. The hub router has got 3 static routes pointing out to each of the spoke routers. Now obviously you can have various networks coming off the hub networks, and you just add a static route onto the hub network. Just definition of what a stub router is. I know sometimes terms are mentioned and nobody explains them in books and other videos. Gateway of last resort, you can have these as a directly connected network, a static route, or discovered via a routing protocol, and it's installed at the top of our routing table. Command is IP default -network. Generally that command is used with dynamic routing, a dynamic routing protocol. What happens is that actual route is propagated by the routing protocol throughout the routing domain. So we've got a simple network here, a 192 network between routers 1 and 2, and a 172 network on the left of router 1, just on a loopback. I've issued, if you see on router 2, show IP route, and I've highlighted in red, gateway of last resort is not set. On router 1 on the left, I've added IP default network and then 172.16.0.0. What that has done is it's propagated through the routing protocol. On this particular one, I'm running router RIP, and it's installed it as a gateway of last resort on the right-hand router. So if router 2 on the right doesn't have a better route to get to the destination, it will send it to the gateway of last resort. Here's another example on router 1 this time. I've issued, it's going to install a gateway of last resort, but this one isn't been sent through the routing domain. If you look at the last command, I issued IP default -network. So the difference between a static route and the IP default network is the IP default network will be propagated throughout the routing domain. It does differ for different routing protocols, but I don't want to complicate the matter at the moment. So I've just issued an IP route. Any traffic for any network could go through loopback 0. Obviously you wouldn't do that, but I just want to illustrate my point. And on router 1, it's installed a gateway of last resort to anywhere, a gateway of last resort to anywhere. And you can see this hasn't affected the router on the right. The router on the right is still just got our normal RIP routing protocol running. Default information originate command. This can sometimes be asked in the exam, so I just want you to be familiar in case you haven't seen it before. That's the actual iOS command there. So it's default -information originate, and it's used with dynamic routing protocols. What it does, it allows the routing protocol to be injected throughout the routing domain, or route at least. Generally speaking, people ask the difference, this is used with OSPF. There are tags you can actually add on to the end of the command depending on what area you're using at the particular time. So on the right hand side we've got router 1 and router 2, same IP addresses, networks as before. I've issued the router OSPF 1, I've added 2 networks to router 1, and then I've added the default information originate command. I've added a static route also on router 1. Now we can see on router 2 the effect is that it's installed a gateway of last resort. The gateway of last resort is the IP address on router 1, the left hand router, to get to any network. You may have noticed a problem here. Router 1 is sending all traffic out of its interface to router 2. However, router 2 is sending all of its traffic back to router 1. So if this was actually configured on the network, you'd have a routing loop where all the traffic is sent between router 1 and router 2 and doesn't actually get to where it needs to go.
Welcome to the static routing lab. So fairly simple topology. Router A is connected to router B on a 172.16.1 network with a /30 mask. Router A is connected to router C just with a simple Ethernet connection, a crossover cable. You can use a serial cable if you wish. I just thought I'd change it. The network's 172.20.10 with a 30 mask. Behind each of the 3 routers we've got a network. I've just added an IP address to a loopback interface. 192.168.1.1, 10.1.1.1 and 10.2.2.2. So router A will need to have 2 static routes to get to the networks behind router B and router C, because obviously they're going to have to leave by different interfaces. So this will give us a chance to try a couple of static route commands. So if we go to router A, conft IP route, we want to get to the 10.1 network. So we've got the 10.1.1.0 network. I've put 24 bits of mask in because that's what we've got on the network, and then we might not actually know the next hop address. If our ISP has just given us an IP address, we might end up having to send all the traffic out of the serial interface. Now the serial interface for this router is serial 0/0/0. So next we need to take care of the IP route to the 10.2 network. IP route 10.2.2.0, and then what we'll do here is put the next hop address. So just to mix the commands up a bit, next hop address is going to be 172.20.1.2. 172.20.1.2. So the 172.20.1 network will be in the routing table for this router because it's directly connected. Okay, so I've come out of that. So the next thing to do is ping the 10.1.1.1 IP address. Okay, we got success there, and then ping 10.2.2.2. Okay, and that's worked. You can do a show IP route if this works on this emulator for 10.1.1.1. So directly connected via serial 0/0/0. And if we do a show IP route 10.2.2.2, okay, different output to what I was what I was expecting there. It's oh yeah, sorry, that's because I did an next hop address. So I did a exit interface for this one and the next hop address. So the router basically, because it's a static route, will believe everything you tell it. So whether or not that next hop drops or the exit interface goes down or whatever happens, the router will just carry on trying to send the traffic. That's the drawback with static routes, but you know, a lot of the time would beat you having to configure routing protocols when you've only got a small handful of networks. So have a go at this lab and good luck.
IP version 6 static routing. I'm going to be looking at the routing table as well for IP version 6, and I recommend either first time if you can, or at least on the second time round if you're looking at this video twice, to boot up a couple of routers or packet tracer or GNS3 and follow along some of the commands you see typed here. Now, here's quite a basic network topology that I'm just going to be referring to throughout this presentation. It's only a short one, but we've got three different networks obviously on the left hand side of router 0, one connecting router 0 and router 1, and then one off router 1. They could be put on your, there could be your loopbacks or Ethernet interfaces, whatever you wish. Alright, so I've typed out the command. You can see the difference obviously with the IP version 4, it's show IP route. For IP version 6, it's show IPv6 route. If you hit the question mark, you can see you've actually got quite a few options there that you can tag onto the command. Just your basic show IPv6 route. You can see we've got some connected and local addresses showing there. And if you configure this on your routers, your output should match mine. Connected routes are shown via the C, which you can see when you type out the command on whichever router you're looking at the moment. Your 0/0 is your matches IP version 4 administrative distance and your metric. Via is obviously via learned which interface or next hop address. Now, only directly connected networks will equal 0. Local route signified by an L. We don't see link local networks, which I'll go to in a moment. There's no point because they're not used for routing apart from the fact they're used by the protocols as next hop addresses. The host /128 routes are used for the IP version 6 unicast address. This is what the router uses to process self-directed packets. So as I said, the link local address is not routable, so it's not listed in your show IP route, although when you dig further into the protocols and you look at neighbors, it will show the link local address for the next hop as part of the routing process, but it doesn't show in the routing table. Null 0, it's the same as IP version 4, it's basically a bin for packets if there's no route. Now we don't have classful and classless in IP version 6, there's no need. So the IP version 6, you don't see a classful network with the subnets listed. So a static IP version 6 routes, we've got our network topology here, and you can see I'm pinging the 2 address on the ABCD1234CC B2 network. Right, so configuring a static IPv6 route, IPv6 route, and then I've put the destination network /64, and then I've put a question mark just to show all the available options. So IP version 6 route to the destination address, and here I've put via fast Ethernet, and then I've put a question mark just to show again what our options are. At the bottom, the configuration is I'm just sending all traffic out for this network out of the fast Ethernet 0/1. And then a show IPv6 route will show the static entry that I've configured there. We can also do a next hop IPv6 route to whatever the destination address is, or destination network via the next hop address on the static route in the table again. And we can have a default route as well. I've typed here IPv6 route, a default network address, which is all the zeros, and then I've got a next hop address configured in there, and that will send all traffic to whatever network to the above address. Welcome to our IPv6 static routes lab. This is our topology, so please pause the video if you just need to check out the addresses. They look very similar. The last part is all the C's, all the D's and all the E's, depending on which network we're using. We've got a loopback interface on the left-hand router, router 1, and a loopback interface on the right-hand router, router 2. Now, I've actually already configured these IP version 6 addresses to save time in the lab, and I covered how to do IP version 6 addresses in another lab earlier on. So you can see these are the addresses I've added. All the interfaces are up because I no-shutted the fast Ethernet. You don't need to no-shut loopback interfaces, obviously, because they're logical. I'll do a show IP version 6 interface. I actually should have put brief on the end of that just to save a bit of space. And you can see our two IP version 6 global addresses configured on router 2. So I'm going to look at two ways of adding static routes using IP version 6. And because of the length of the addresses, I find it useful to cut and paste addresses. With IP version 4, obviously, it's pretty quick just to type them out, but because they're longer and therefore easier to make a mistake, I do like to cut and paste. So router 1, I'm copying the loopback address here, and we're going to configure a static route on router 2 so we can get to the network off the loopback on router 1. So back in the command line, go into config mode. This is all on GNS3, by the way. IPv6 route. Now we're going to, is the first part, which network or host are we going to? And I'm just going to take the host address off and do the entire network. I could do a host route, but I want to reach the entire network. I'll type question mark, and we've got several choices of interface. Obviously, we've got a fast Ethernet 0/0 attached. We want to put the link local address on because if we're using an exit interface, we need to add the link local address of the next hop. Otherwise, our static route won't work. So I've pasted that in. I've got it from router 1 and I've pasted it in. Next thing to do is test to see if this static route has worked. Obviously, before you do that, you want to ping between router 1 and router 2 anyway. So ping, put in the IP address I want to ping. Which again, I'll cut and paste from router 1. So I've pasted in the loopback address, press enter, and that ping has been successful. So we know our static route has worked. Now on router 1, I'm going to configure a static route to get to the loopback network on router 2, but I'm going to do it in a different way. So default route, any traffic for any network, so I've signified all the zeros here, the IP version 6 way of doing it. I could use an next hop, but I'm going to do an exit interface here. So I'll find the next hop address, copy that. So to get to anywhere, go via this next hop address. And I'm going to ping the IP address off loopback 0 on router 2. And that ping has been successful. Do a show IP version 6 route, and you can see at the top there I've got a static route configured. And it's going via our next hop address on router 2. Show IPv6 route on router 2. And you can see we've got a static route going out of Ethernet 0 via the link local address.